Hello and welcome everyone. Thank you for joining us for the third Hangout on Air of the open application period of the fall 2016 cycle of igniteCS. I'm Sloan, based here in Mountain View. I'm a program manager with igniteCS and the student and faculty lead for the program. We have some great guests joining us today.
Hi, my name is Alicia. I'm an instructional designer here at Google working on supporting the igniteCS program. And my background is in STEM education and research in cognitive psychology.
Hi, I'm Melissa. I'm with the partner organization of igniteCS Big Code. I'm one of the co-founders of the company, and we're a computer science platform. And we teach students to code by connecting to the things that they love and do in their daily lives. And so I'll be sharing some more information and resources with you all today.
And I'm David Tenhover from Joy Labs Makey. I'm the COO of the company. We produce a little hardware board that focuses on creativity and invention literacy.
Excellent. Thank you, everyone, for joining. Let's give a brief overview of what igniteCS is as a program, just in case we have any first-time viewers out there. As I mentioned, this is our third Hangout on Air. Every application cycle will hold these to give interested applicants an opportunity to learn more about the program, as well as have the opportunity to ask us questions. So please feel free to submit your questions live. We'll be able to answer them as they roll in. igniteCS provides funding and resources for groups of college and university students to impact their communities through computer science mentorship. So you, as the students, design the curriculum and the program, tell us what your community needs, and we provide the resources for you to implement that. And you get some pretty cool perks like working with our amazing partners. Unfortunately, not all of our partners could join us today. We'll be talking about who else we're working with this year. And you get some goodies from Google as well. So what do you need to start an igniteCS program? We have 5 eligibility requirements. The first is that you are a group of at least 5 undergraduate students from an accredited college in the United States or Canada, and that 2 of those 5 mentors, 1 upperclassman, a junior or senior, and 1 underclassman, a freshman or sophomore, serve as the student leader. And student leaders are involved in the operational pieces of your igniteCS program and are also the point people for the igniteCS team. The next eligibility requirement is that you have a faculty advisor or an advisor from your community partner who will help you with some of the more sticky questions like signing permission slips or getting people from point A to point B. And then, as I mentioned, you need a community partner, the people to whom you plan to deliver your mentorship. Some K-12 students in your community, maybe at a local middle school or at a Boys and Girls Club. Finding an organization that you and your group of mentors value and to whom you want to provide some really valuable and exciting computer science experiences. What we're really looking for in applications is that the budget you propose, how you spend your igniteCS funding, and the curriculum that you plan, what you're going to be teaching to your mentees, align really closely. We're also looking for a program that is reasonable given your scope. Some igniteCS programs work with 10 mentees, some work with 200. There's all sorts of formats. You can do a summer camp or an after-school club. We give full program design to you, but we do look for evidence that what you plan to do is reasonable and achievable. We want you to have big, crazy dreams about what you can accomplish with igniteCS. We also want to make sure that you can actually accomplish this. And then we're really, the biggest piece that we look for in the applications is clarity. Do we have to sift through sentence after sentence and we still are not really sure what it is that you plan to do, or do you have an action plan that if you had your igniteCS resources, you could go tomorrow and take off with it? If you have any questions about how to craft your igniteCS application, we have a brand new application info section on our webpage, g.co/igniteCS, and the igniteCS team is here to answer any of your questions at any time. You can send us an email at ignitecs@google.com. Okay, that's enough of me. Today's topic is teaching computer science. One of the biggest questions that we get is, wow, this sounds really cool. I totally want to do mentorship, but what should we teach? So we're going to spend some time today talking about best practices for mentorship and teaching computer science, as well as tools and resources for designing your curriculum. There are so many tools and resources that you can use in your igniteCS program. There are quite honestly too many to list. So we're going to get started with our guests today. Thanks again for joining, everyone. Could you each describe who you are, what you do and why you do it, and why you're partnering with igniteCS? Maybe Melissa, you can kick us off.
No problem, no problem. So again, I'm Melissa. Sorry if there's feedback. So you know what we are really passionate about at VidCode is creating ways to make computer science more accessible for all students, and so that's definitely something that we share with the igniteCS program, and I'm sure with mentors and those of you who are starting your own programs. And so the way that we think about that is, you know, really targeting students who we feel are traditionally left out of opportunities that come from a knowledge in computer science. And so, you know, we actually started our product thinking about ways to engage more young women. And we're a female-founded company, so obviously that's something that resonates with us personally. But you know, it's something that we think about and think about how much that affects the pipeline of the girls and women who will grow into the fields of technology at the professional level. So we were thinking about ways to engage more girls, and that really transferred into a way to engage, again, all the students who we feel are kind of left out of the mix. And so our approach to solving that is really to make a connection between what computer science is and what learning to code is, and with the things that students are doing in their daily lives. And so our target there is connecting to, you know, what are the hobbies that kids are doing every day, and how can we kind of draw connections there. And so we really specifically focus on the idea of digital media. We know that we really focus on middle school and high school as our demographics, and so what are kids doing a lot of the time? They're focusing on photos and videos and apps that enhance those things, and so we're very much inspired by those tools, things like Instagram and Snapchat and YouTube, and all the things that are what we see kids doing on a daily basis. And so our curriculum and our platform is really designed to let kids sort of make those things while they're learning to code. Whether that's building a video filter for, you know, their own recorded webcam video, or it's making a stop motion animation with their photos, or making a kind of augmented reality Pokemon game. All of those things are good examples of the kinds of things that we really want to give kids the opportunity to create while learning to code. So that's kind of really what we've seen resonate and what we've seen work well is, you know, creating accessibility through engagement. You know, and really giving kids an entry point, as well as teachers and as well as, you know, adults who are learning along with our students, giving them a point of access to really kind of start into what, as Sloan said, is kind of a overwhelming world of where do I start and how do I learn, and I know it's important, but what's the first step? And so that's kind of our little tiny sliver of a contribution to that, you know, really trying to meet students where they are and take the things that they're interested in and give them that as an entry point to learn to code.
That's fantastic. I have a ton of follow-up questions, but I told David that he could do his introduction first before I started doing that. David, take it away.
Hi, thanks. I'm Dave. I help run Makey Joy Labs. So I'm kind of a business person, but I've got 20 mumble years as a programmer, and so I've kind of got a foot in both camps. Makey really focuses on creative confidence. It focuses on allowing people to come up with an idea and express the idea. And of course, the computer is a really important part of that, and programming can be an important part of that. It's not necessarily an important part of that. The idea for us is that we live in an invented world. You know, the world that we're surrounded by is made up of objects that are invented. And our thesis is that inventing's not magic. It's stuff that people do. And so we focus on this idea of invention literacy. How do we teach people the language of invention? And of course, computer science is, in our world, a deep fundamental component of that invention literacy. And so, you know, the whole idea is that we've got this tool that allows you to become an inventor very easily. It's got a very low floor to participation, but it's got an incredibly high ceiling of expression. So you start really easily, but then you can start doing amazing things. And so that's really why we're here. You know, we understand that for us to live in a better and healthier world, we need to have programmers who aren't just white guys creating stuff. You know, we need to have diversity, and we need to have people who come from different communities and different perspectives, contributing to the world that we live in, and that's really what we're here to do. You know, the product was designed to bring people into this invention game, and not just the usual candidates. So
that's really fascinating. Melissa and Dave, you both highlighted two of the biggest pieces of igniteCS that kind of get me up every morning, which is increasing access to computer science education and making that access available to everyone, making sure that anyone who's interested in participating in computer science or learning how to create technology or how to solve the next big problem has the ability to. So I just thought it was a really interesting that you both kind of hit on those 2 points, increasing access to quality computer science education. You know, our mentors are out there providing instruction that perhaps many of the mentees don't have access to. And it's a really valuable opportunity that we as educators have to kind of pass a torch of knowledge onto the next generation, or you know, your little siblings or something. Alicia, I'm hoping you could tell us a little bit about what it is to be an instructional designer.
Okay, well, I'm learning what that means every day still. My role as an instructional designer at Google is, well, how I got here is not a traditional path, so that's also something that is interesting in working with a program like igniteCS. So my background is, I mentioned briefly, I'm a cognitive and developmental psychologist, so my expertise is in how children learn words, concepts, categories, specifically, and with applications to the STEM fields. So my road to my career in technology was paved on basic science. So I am a scientist, I'm a female scientist, so there are a lot of things that I've experienced while I was working in a different field that are highly applicable to what I'm doing now. So how I got to igniteCS, I applied my cognitive science background to middle school science curriculum first, and have also specialized in early math, and so I have a lot of background in early science and math. And then in previous jobs, I focused more on inspiring creativity in children through technology and tools like animation tools. I've worked on learning games. I've worked in hardware. I've worked in, more recently, specifically early computer science education. And so igniteCS is actually one of my side projects. My real day job is actually training Google engineers. So being a part of igniteCS allows me to kind of tap into my initial passion of supporting children's learning through invention and creativity. And yeah, if anyone has any questions about how to make their programs developmentally appropriate for different age groups, I have a lot of experience in that, and just having a good idea of the landscape of what's available now. And it's not just about writing code, it's really about creation and invention and being creative.
Absolutely, and you brought up a great point. If anyone has questions for Alicia, we have another instructional designer who's not on the call today, Face. He's based in London. If you have any questions for our instructional designers about, is my program making sense? Am I teaching folks to run before they crawl? You can go to g.co/ignitecs and head over to the About Us section. You can email all of the igniteCS team members directly and ask your catered questions. We really encourage you to do so. All right, let's jump back to Melissa. You know, I've come across a lot of platforms in the computer science education world, and many of them are guided. If you're an individual who comes to the platform, you know, you're kind of walked through a progression that is very well scaffolded, and you get all of those concepts laid out. But how can our mentors use VidCode as a platform for education in computer science?
Yeah, no, and I mean, I think it's really always kind of a combination of those two things. One being, you know, very much a student-led and student-guided experience as far as, you know, what's available online, and a lot of things definitely follow that format that you described. But I also think that, you know, there's a portion of, you know, what our educators and, you know, what kind of the facilitators for the students' learning is that you know, needs to work in tandem. So the way that we think about that is, you know, we always have things that are going to speak directly to the students. So, you know, like they'll use the video filter project, for example. That's going to be something that students can go through on their own, and, you know, they can really go through that in a self-guided way. But what's important for for mentors and educators is to, really have a knowledge of, what are students learning there, and, what are the things what are sort of the concepts that are being absorbed, so that they have, this ability to look down on, what the students are doing and analyze it and say, they've covered some, fundamental topics in JavaScript, and, maybe now they're ready to move on to the next thing, and really sort of provide some guidance around that experience and around what the students are learning. So, I think of it as, this is the way VidCode works, but I think it's pretty common across tools and platforms is, students are they're gonna plow through stuff a lot of the time, and, they're gonna create cool games, and they're gonna make all kinds of sort of produce all kinds of stuff, they're going to create, as you're all saying. That's like a big word here, but it's also, I think, important to come back and you sort of be able to check those pedagogical boxes and say, what are the concepts that they cover, kind of the things that maybe the students don't know that they're learning, and we want to make sure that we are able to, on our end and for our educators, just keep track of that stuff and be able to essentially present what the learning outcomes were. And so I think of, for the teacher's perspective on VidCode, it's that part. It's kind of having those materials and those resources to be able to see what your students have accomplished and reinforce them, and even if it's just giving them direction. It might not be that you're delivering the lessons, in a traditional format, but maybe just giving them guidance as far as, maybe pointing them in the right direction as far as what they can do so that they get sort of a holistic learning experience. And in the VidCode context, that really means specifically JavaScript. Again, it's the language that we teach, and so fundamentals of that language, and thinking about how, they can use our tool to achieve that level of competency.
Fantastic. You had mentioned there are resources like lesson plans or being able to check in with the process or the progress of folks who are using VidCode. Is
Yep.
that a resource that comes kind of standard with VidCode?
That is something that actually, I meant to communicate this, but that's something that we're offering to the partners here at a discounted price. And so that's something that I'll pass on to Sloan here, but for 25% off, like the sort of standard rate there, that's something that we're giving you the mentors access to, and give them just a little bit of additional visibility. I think there's also a lot of stuff that can be done, at least without that at the beginner level, where students might not need as much of that kind of tracking, but for more intensive and longer learning, depending on the amount of time that students are going to spend with us, that is something that I think is valuable for kind of a longer term usage. So
yeah. And for mentors who are thinking of using platforms like VidCode, there are some other platforms we'll mention in just a moment. If you're not, if there isn't a background, kind of handed off to you, here are some lesson plans that you can follow. Here are some ways that you can check into your students' progress. I would encourage you to just sit down with the platform that you've identified as being valuable and familiarize yourself with it as mentors, so that if your students get stuck, you can help them debug. If you know that a particular lesson or a particular activity in VidCode covers really heavily, a couple fundamentals like loops or conditionals, you can know ahead of time that those things are coming and push everyone on pause and say, all right, here's what loops are, and then get them started on the program so that they're really understanding, I know what a loop is and here's what it does. Let's jump back over to Dave. There is so much that can be done with Makey Makey. Do you have some paths to start our mentors down for some activities or lines of inquiry for them to follow?
Yeah, I mean, the whole idea of Makey Makey is that you are able to plug everyday objects into your computer. That's kind of the thing, right? And the canonical demo for us is the banana piano. So obviously, find a bit of music software, plug the Makey Makey in, attach the bananas, and start playing music. And I know parts of my team who are probably watching this going, no, not the banana piano. I mean, we demo it all we demo it all the time, and it is, it as an icebreaker, as a conceptual icebreaker, it's just super important. The next step is literally aluminium foil and cardboard. Creating switches and having people interact with these very simple inventions that are literally made with a craft knife, and so it's really about that graduated stepping process. It's about getting to grips with this idea that you can control your computer with objects in the everyday world, and then allowing people to build on experience and build on exploration. It is really super important for us that people do explore, that they make mistakes, that they try something, and that, you know, it doesn't work, and that process of it not working is as enlightening and sometimes more enlightening than an easy win, right? You know, there's stuff embedded in failure that's so rich that we kind of, you know, we encourage people to go down that path, and that's the joy of bringing everyday objects to the computing environment. Some of them are going to work, some of them are not, and so that's kind of that. Those are the broad recommendations.
Fantastic. We'll jump back into exploration and failure in a little bit. But first I want to feature some of the other partners that igniteCS is working with this year who are unable to join us on the call today. So first is GitHub Education. They really want to highlight that you can access their student developer pack for free, which comes with a impressive wealth of resources and documentation. They are also want to highlight that GitHub is a place where people work on software together, and we hope that you and your mentees are certainly implementing that collaboration there as well. We're also very excited to be working with LittleBits, a platform of easy-to-use electronic building blocks, empowering everyone to create inventions. You know, you dream it, you can do it kind of a thing, just like you know, you can invent pet feeders, you can keep your siblings from breaking into your room with a security system. There are so many amazingly fun projects to get started with at LittleBits. And we're also working with Particle, and they provide hardware like Wi-Fi and cellular connected microcontrollers, as well as the Internet button, a ready-to-use Internet of Things device that allows you to connect all of your devices. So I cannot even begin to thank our partners for their commitment, for their support, and for our partners who retail hardware devices. We have some really amazing and exclusive discounts for accepted igniteCS programs. So Dave and Joy Labs is generously providing 40% off Makey Classic to accepted igniteCS programs. Particle is offering a 15% discount on their online store, and LittleBits is offering a 10% discount on their online store as well. And VidCode is also providing a discount for their educator resources that support VidCode. Not only are they providing discounts and these wealth of resources and knowledge for you to get started, but many of our partners are also willing to join your mentorship session as guest speakers. Many igniteCS applicants want to bring guest speakers to their mentorship sessions to get their mentees excited about what it means to work in the field of technology. And our partners are generous enough to donate their time and energy to our mentees. So if you're interested in having any of our partners join some of your mentorship sessions to speak about working in the technology space, you can contact us when your igniteCS program has been funded, and we will work to arrange that for you. Thank you again for all of your generosity and support. We're also providing links to our partners in the description of the YouTube video, so if you want to poke around on their websites and get excited about what they have to offer, please do so. We are, again, so thankful for everything that they're contributing to this application cycle of igniteCS. Like I mentioned, one of the biggest questions that we get from applicants is, I'm so excited to do this, but what can I teach? I wish I could list all of the things that our igniteCS mentors have used in the past, but I'll briefly run through some of the most common that we see across programs. I'm not going to get very in-depth about what these elements are, but if one of these elements that I mentioned sounds interesting to you, feel free to give us an email at ignitecs@google.com and we can talk a little bit more in depth. One resource that is exceptionally popular is CS Unplugged. They have a repertoire of offline resources, no computer required, to get your students started learning computer science fundamentals and moving around. Having a physical connection to learning is really important, particularly if you have younger mentees. I had mentioned some platforms earlier for learning computer science. Not only do we feature VidCode, but many of our students are also working with CS First, which uses Scratch. I'll get to that in a moment. to facilitate learning computer science concepts around themes like sports or friends like storytelling, like fashion. So find the concepts or the themes that would be really exciting for your mentees, get them started on those activities there. I mentioned Scratch. That's a visual block-based coding language that if you're using younger mentees or mentees who have never had any experience with coding, visual languages are a really great way to get them started. They don't have to worry about syntax, it's drag and drop. So Scratch has been exceptionally popular, and they have resources for educators. Blockly also has scaffolded games for learning, a bunch of online documentation. Sphero is another company that we are actively speaking with a potential to partner with igniteCS, and they have this amazing robot that comes with a suite of educator support resources, and that also uses a visual programming language to, you download the app, you use the visual programming language, and that's how you control your Spark Sphero robot. So getting more into hardware, like I mentioned, robots are a really common theme in a lot of igniteCS programs. Lego Mindstorms or WeDo are very popular. I mentioned Sphero just now. There are really so many robots that I can't list all of them here today. Many folks also choose to use Arduino or Raspberry Pi hardware. Both have very low-cost components that can help you keep your mentorship sessions sustainable. If igniteCS were to disappear, how might you be able to continue your mentorship sessions in the future? And looking for low-cost or reusable resources is a great way to do that. Another great low-cost resource for facilitating programming, it's possible that you might not have a technical infrastructure at the place where you're hosting your mentorship sessions. We're more than willing to help you look for affordable computers, Chromebooks. There are some great tablets that have, full computing capabilities as well. Contact us. We'll help you look for those low-cost resources that will perfectly suit your program. I wish I could list all of these here. We've got App Inventor to get your students started with building their own apps that uses Scratch. We've got Pencil Code, which lets your students toggle between text-based coding and block-based coding. The list really does go on. Contact us. We know what our mentors have done in the past. If you want to find out if something that you think would be useful in your mentorship program sounds good, contact us, ignitecs at google.com. Reach out to our instructional designers through our About Us page. We have too much information to give you about what you can use in your mentorship program. But the most important point is that your 5 ongoing mentorship sessions that you run with igniteCS, I just realized I forgot some eligibility requirements. 5 ongoing mentorship sessions that focus on computer science or computational thinking. How you combine computer science with any other subject or topic is up to you, but that those fundamentals of computer science really are the core of your mentorship. And another important piece that I think we all spoke to a little bit earlier that I want to call out as a eligibility requirement for igniteCS is fostering an inclusive environment for those who are currently underrepresented in igniteCS. Go to our website, g.co/ignitecs. We have a FAQ item that specifically explains what we mean by fostering an inclusive environment for underrepresented groups in computer science, and watch our previous HOA to learn a little bit more about how you can foster an inclusive environment and create a mentor and mentee team that truly is inclusive. So I'd like to focus a little bit on best practices when it comes to teaching computer science and just teaching in general. For many of our mentors, this is their first experience with computer science or education instruction. And 2 resources that I do want to highlight as having great tips for getting started teaching computer science. NC WIT, their website is also listed in the description, the YouTube description for this event, and csteachingtips.org have a wealth of resources for how to teach computer science effectively, engagingly, and reaching a diverse audience as well. So, like I said, those links are in the YouTube description. Give them a check out.
A click.
Mm-hmm. Check them out. I don't know. So I want to ask everyone, what does it mean to be an educator, to be a mentor, and what can our first-time mentors anticipate on their first day, on their first mentorship session?
Is that a question for us?
For
Sure.
everyone.
Yeah, I mean, I think you guys touched on it earlier, Alicia, when you were talking about, just owning or even just familiarizing yourselves with the tools. I think that like we're at a point where, everyone's kind of a learner. It's like there's this really unlevel playing field when it comes to computer science, and that's because in the past a lot of people have learned it. They're learning it outside of school. They're self-taught. A lot of the traditional paths, as you spoke to, are through people who are self-taught. So I think the idea of kind of owning that part of the learning process as a mentor is really important. And so I work, not personally in the classroom, but I work with many teachers who are the ones who are delivering CS material. And I think it's just about, even building your own confidence and putting yourself in the shoes of your students, which is, this is a new field, and there's going to be an intimidation factor, but I think there's just something about kind of owning that for yourself as a mentor and being okay with that, and like there's vulnerability there, and that's okay too. But I think the best thing that you can do for yourself is treat yourself as a student and know that there aren't always you're not going to have all the answers, but that's really where community comes in. And community can come from a lot of places. It can come from your classroom itself, from the group of students that you're working with and helping each other, and this idea of even pair programming, you're working with one another to accomplish a result. But there's also online communities. So a lot of what the team has mentioned here, there's just so many tools, whether it's some of those best practices or even just a bunch of cool tools out there that have a thriving community of teachers who are sharing things with each other. I think Scratch does a great job of that. And so I think just sort of being okay with knowing that you're learning as well, and being okay to ask questions to your community and also to your students. You're all really learning together, and I think that's an awesome way to approach teaching as well. So I would just encourage just ownership of that mindset. And from our perspective, we are a support team to our community. So that means reaching out to us when there's a question, and whether it's a technical question or just a how do I do X question. I think that's a big part of the learning process, and we definitely feel responsible for supporting our educators, and the mentors would be a great example of that.
Absolutely. Curiosity, you mentioned, is a very important component, especially when you're talking about mentorship. And mentorship really is different from teaching. Often in teaching, you're trying to accomplish a goal, and you have to measure that goal with tests. There's often, the lecture format and homework assignments that all get you to a point of being able to do a certain activity or concept. But with mentorship and with igniteCS, we're really looking for sparking curiosity, giving people the tools that they need to be curious, be inventive, solve problems, challenge each other as mentors and mentees to think big and accomplish awesome things. And you're right, Melissa, there will be moments where some of your students are going to ask you a question that you haven't considered before. So look them in the eye and say, I've never thought of that. That is an awesome question. Let's find the answer together. So another thing you had mentioned, Melissa, is mindset. And that's actually a really important topic when you're thinking about learning a new skill in particular. And so one thing that I do want to highlight is growth mindset, which is the belief that skill and ability come from persistence and effort, and it's not, the opposite of growth mindset is fixed mindset, which would be you have it or you don't. You're kind of born with it sort of thing. Computer science is absolutely one of those fields where through persistence, through effort, through curiosity and exploration, you can progress, you can accomplish real things that impact your life, lives around you. So Alicia, what does growth mindset facilitate in learners?
Well, first of all, fixed mindset, like the idea that you're either like a math person, you're not a math person, you're an engineer, you're not an engineer, that's a total myth. So anyone who thinks you're born like a math person or not a math person, I don't know where that came from, but it's a pervasive myth that should hopefully be debunked relatively quickly. So growth mindset is actually, or persistence is what I've talked to a lot of teachers about this, and when you ask a lot of computer science teachers, it's persistence that is the #1 thing you learn through computer science. It's not how to write lines of code. It's not how to make a game or write hello world on a screen, which whatever, that's a great way to start. But it's really just learning how to solve problems, how to deal with challenges as they come, and a fixed mindset is somebody who probably, like, in terms of engineering, you need a growth mindset to succeed. So if you want to work in technology or a field, any creative field even, other than a STEM field, you really need to embrace failure as a learning opportunity and just get better as you try harder. And so what growth mindset helps you do is learn how to go through challenges. And any Google engineer will tell you that launching a product is very challenging, and you encounter things along the way you never thought of. Anyone that's worked at a startup has probably failed multiple times. If they haven't yet, they're very lucky and will fail at some point in time. Or they'll fail at one thing one day that they have to figure out how to solve before moving on to the next thing. So that's actually one of the most important things you learn through a STEM field, just learning how to deal with problems, not giving up when it's a tough situation. And in the end, working through those usually gets you to a better place than either giving up or just trying or just stopping, and not moving forward and just calling it, or like starting with some, like just dropping the project and moving on to something else, if that makes sense.
Absolutely. And as mentors, we really need to embody growth mindset. If you've allocated about an hour in one of your sessions for your students to accomplish a certain task, and one of your mentees runs up to you and they finished it in 35 minutes and they're so excited and they want to know how they can expand on it, avoid phrases like, "You're a natural," or, "Wow, I can tell that you've really been, that you've had some prior experience with this." This increased self-efficacy, which is praising hard work and effort and not things that are outside of a mentee's control. You might come across mentees who have parents who are engineers or computer scientists, and they've been coding for 3 years already, at age 12 maybe. And so saying things like, "You have been working so hard on learning this concept. Yesterday, you couldn't even run this program, and today it's running flawlessly in ways that I didn't anticipate. You've come so far." Embodying growth mindset, increasing your mentees' confidence in the fact that they can do anything if they put their mind to it, is really important in creating a fun, productive, and explorational environment in your sessions.
Or even if it's like really, let's say they did something and it's really impressive, ask them what else they can do with it. Push the boundary of, like, let's say you program your robot to go through a maze. What else can you do? Can you create a more interesting maze? Can you teach it to go backwards through the maze? Can you turn it into a game with a partner? Like, there's many ways to enforce some of these concepts, and just get them to challenge themselves and how they're thinking about things.
That actually brings up a great point. Concepts versus maybe what I would call outcomes. So concepts in the sense, there are a bevy of things in computational thinking and computer science that are just fundamental concepts. Algorithms, decomposition, abstraction, data analysis, modeling. And so communicating those concepts to your mentees is really what igniteCS is all about. But the way that you create a mentorship opportunity around these concepts as opposed to a teaching opportunity is focusing on those outcomes. Okay, great. You understand what an algorithm is, but what can you do with it? And David, I'd like to hear a little bit about project-based learning, focusing on those outcomes and processes and putting fundamentals in action. So what relationship do curiosity, learning, and outcomes have in that CS space?
It's absolutely crucial. The experience that I've had both as a programmer but also as a mentor and someone who has delivered product has been that it all works because people are curious. The moment you stop being curious, you may as well just give up the game, right? It's that the curiosity is where the drive comes from, and it is that ability to explore a thought space and encourage others to explore that thought space, to uncover the little nooks and crannies that lead you on to the next thing and the next thing, right? You know, if your drive is to create the, you know, to solve the next biggest problem or create the next greatest thing, you have to cover a bunch of ground that other people have covered. You know, and that can, if you're not a curious person, that can get kind of boring. You know, it's kind of like, oh, well, people have solved these problems. But what happens is that if you're curious, you start to uncover these little avenues of thought that people didn't see, didn't go down, ignored, and that's yours, you know, and you can follow it, and then it doesn't take too long before you're into new territory, before you're into, you know, creating these great new things. But you would never have gone there if at that first point in time you didn't say, hey, I wonder, you know, and then repeatedly gone, I wonder, you know, and encourage the people around you, you know, as a mentor, right? Encourage people around you to go, I wonder. One of the big issues that I've found personally is kind of this chauvinism around complexity. I'm a complexity person. I get a kick out of complexity. But the greatest insight I've ever had is around people who aren't that, people who look at things for the simplest solution and who are driven by a curiosity for the simple. And that has led me into a whole range of really valuable spaces. And so if we're looking at how to be a mentor, often encouraging people to do simple explorations can be far more fruitful, because you can then go, that's fantastic, what if you go in this direction? And they've got the confidence, they've had that feedback, they know they're good at something, you know, so it's really easy for you to go, well, take this next simple step. And they go, well, hell, you know, I took a first simple step, that was awesome. They've got the confidence, they've got that drive, that curiosity has had that feedback. And so, you know, I think it's, yeah, super important.
That's fantastic. So, you know, in discussing these kind of best practices, we've kind of come up with almost a formula, I would say, which is, you know, identify what it is that you love about computer science. Partner that with the fundamentals of computer science and computational thinking, those bedrock items, you know, abstraction. Find ways to communicate those fundamentals in fun ways, and then give your mentees the opportunity to explore and create with those fundamentals by focusing on an outcome that those fundamentals are the process to achieve. So I do want to take one question that I see here, which asks, essentially, that this individual has worked in hackathons before where you've got such a range of experience, like I mentioned, there's students who have been programming for years on their own, and then people who are really excited to make their first app, but they've never known where to get started. So how do we as mentors and educators handle, you know, potentially a very diverse range of experiences with computer science? And what we have found and have heard from our mentors is really to kind of close the circle, use those differences in experience levels as an opportunity for learning and collaboration. So, you know, anticipate a range of experience levels, circulate the room to prompt discussion, address problems as they might come up. If you know that there are some students who take a little bit longer to implement, have a mentor sit with them and work through their projects as they gain that confidence and that curiosity. And if you've got those students who finish their hour-long program in 35 minutes and are coming to you for more, have them work with your other students and encourage them to think in new, big, fun ways. Leveraging the fun and curiosity and wealth of knowledge in your classroom is a way to get everybody involved and excited. Thank you again, everyone, for joining us today. I wish we could talk for days about this topic. There's just so much to cover. Alicia, Melissa, Dave, your time is valuable, and we really appreciate you being able to speak with us today and for your general support of igniteCS by and large. Like I mentioned, all funded programs receive access to discounts from our stellar partners, 10% off the online Littlebit store, 15% off the online Particle store, 40% off the Makey Classic through Joy Labs, and a discount for the educator resources through VidCode as well. Join our next Hangout on Air on September 8th, where we'll be discussing on-the-ground logistics of coordinating a mentorship program. Transportation, scheduling, mentor management, permission slips, you name it, we'll dive deep. So find our calendar of events in the application info section of our website, g.co/ignitecs, and of course, email us with your questions about your application at ignitecs@google.com. We're here as a resource for you. And as a final thing, be sure to check out the links in the description of the YouTube page for this event, where we have links to our partners as well as to NC-WIT and CS teaching tips, some great resources for you to get started learning about how to teach computer science in fun and effective and inclusive ways. Thank you again, everyone, for joining us, and we'll see you next time.
Thank you.
Thank you, guys.